In this video, I will show you how to find the increasing and decreasing intervals of functions like this, and I will show you how to find the relative extrema, the local maxima or minima, and I will show you how to justify all of your answers. We can find f prime term by term. The derivative of sine is cosine. The derivative of cosine is negative sine. The negative will come here to the front and turn this into a positive. So we have positive radical 3 sine x. That's it. This is the derivative. Now we need to find the critical numbers that will make f prime equal 0 or make f prime undefined. But there are no values of x that will cause cosine or sine to be undefined. So we don't actually have to worry about this option. So setting f prime equal to 0, we have cosine x plus radical 3 sine x equals 0. Subtracting radical 3 sine x from both sides, we have cosine x is equal to negative radical 3 sine x. Let's divide both sides by sine x. This will give us cotangent x. So we have cotangent x is equal to negative radical 3. Because of course these cancel each other out. I am more comfortable with tangent than I am with cotangent. So I'm going to do the reciprocal of both sides and write tangent x is equal to negative 1 over radical 3. You might be more familiar with this as negative radical 3 over 3. These are the same. Right now you should be asking yourself, what is the reference angle for this equation? Ignore the negative sign for a second. The tangent of what angle is 1 over radical 3, or radical 3 over 3? Hopefully you memorized every value on this chart back in pre-calculus, including the fact that the tangent of pi over 6 is 1 over radical 3. If you haven't memorized these values before now, please pause the video, write this down, study it, and make sure you memorize it. But for right now, tangent of pi over 6 is 1 over radical 3. So that is the reference angle. There are 4 angles on the unit circle that have a reference angle of pi over 6. There's one in every quadrant. The tangent of any of these angles will be some kind of 1 over radical 3. But 2 of them will be positive and 2 of them will be negative. So you needed to know that tangent is positive in the first quadrant and in the third quadrant. Tangent is negative in the second quadrant and the fourth quadrant. We want the tangent of x to equal negative 1 over radical 3. So we want the solutions in the second and fourth quadrant. These angles are 5 pi over 6 and 11 pi over 6. So these are the two critical numbers. We need to put these numbers on the number line and make a sign chart. Make sure you label your sign chart as f prime. I put 0 at the beginning and 2 pi at the end because we are limited to that interval overall. We need to figure out if f prime is positive or negative in each of these intervals. So let's do some test values. What about a value between 0 and 5 pi over 6? So that's between here and here. Well, pi over 2 is on that interval. So cosine of pi over 2, cosine's the x value, so this is 0, plus radical 3. Sine of pi over 2 is 1. So this is going to be positive. What about between 5 pi over 6 and 11 pi over 6? Well, that's between here and here. Pi is in that interval, so let's just use pi. cosine of pi is -1. It's that x value, plus radical 3. Sine of pi is 0 because it's the y value. So that means this term is gone, and we just have -1. So this is a negative value. For this last interval between 11 pi over 6 and 2 pi, it's okay to go ahead and use 2 pi itself. So cosine of 2 pi is 1, and the sine of 2 pi is 0. So that's going to wipe this out, and we're left with +1. So this is a positive value. Because this is the only row on our sine chart, then we really have found that f prime is positive in this interval, negative in this interval, and positive in this interval. That means that the original function f of x is going to be increasing in this interval, decreasing in this interval, and increasing in this interval. So we would say f of x is increasing from 0 to 5 pi over 6 and from 11 pi over 6 to 2 pi because f prime is positive. F of x is decreasing from 5 pi over 6 to 11 pi over 6 because f prime is negative. But we can go further and talk about the relative extrema. Notice that before 5 pi over 6, f of x is increasing. After 5 pi over 6, f of x is decreasing. That tells us that we are looking at a relative max. See how it's at the top of a hill. And then looking at 11 pi over 6, it was decreasing before 11 pi over 6, increasing after 11 pi over 6. So that tells us that we have a relative min here. One thing that you have to be careful about, you cannot mention increasing and decreasing when you justify this. You have to use the first derivative. So we have to go back to the fact that there is a relative max at 5 pi over 6 because f prime goes from positive to negative. That's the way you have to say it. So let's go ahead and write this up. You say f of x has a relative max at x equals 5 pi over 6 because f prime goes from positive to negative. Can you guess what we will say about a relative min? We'll say f of x has a relative min at x equals 11 pi over 6 because f prime goes from negative to positive. Let's find f prime term by term. So the derivative of sine squared, we have to do the chain rule. First we take the derivative of the outer function by putting the 2 in the front. So we leave this inner function of sine x, but then we multiply by the derivative of the inner function, and the derivative of sine is cosine. So that's the derivative of the first term. Moving on to the second term, the derivative of sine is cosine. So that is the derivative. Next, we need to find the critical numbers. These are the values of x that will either cause f prime to equal 0 or be undefined. There are no values of x that will cause cosine or sine to be undefined, so we don't have to worry about this part. So let's just set f prime equal to 0 and solve. I'm noticing that we have cosine in both terms. So let's factor out that common factor, put it out in front of some parentheses, and see what's left on the inside. Well, if we take away the cosine, that's going to leave 2 sine x. And if we divide out this cosine, we're left with 1. Now let's use the zero product property and set each of these factors equal to 0. Subtracting 1 and dividing by 2, we have sine x is equal to -1/2. So we just need to find the solution of both of these, which you should be able to do in your head very quickly. Where will cosine equal 0? Well, cosine is the x value on the unit circle, so the x values will be 0 at the top and at the bottom. So we're talking about x equals pi over 2 and 3 pi over 2. So these will be two critical numbers that we will put on our number line in a minute when we make the sign chart. But what about sine x equals negative 1/2? I encourage you to think in terms of a reference angle. So ignore the negative sign for a second. Sine of what is 1/2? Hopefully you're jumping out of your seat going, pi over 6, we know this. But there are 4 angles that have a reference angle of pi over 6. There's one in every quadrant. Sine of any of these angles will be some kind of 1/2. It's just that 2 of them will be positive and 2 of them will be negative. So we want sine x to equal negative 1/2. What are the 2 quadrants where sine is negative? Well, sine is a y value, so it's going to be negative in these 2 quadrants. So let's focus on that. So these 2 angles are the solutions. This angle in the 3rd quadrant is 7 pi over 6. And this angle in the 4th quadrant is 11 pi over 6. So we have 4 critical numbers to put on the number line to form the sign chart. Let me point out a couple of features of my sign chart. First of all, don't forget to label it as f prime. Second of all, looking at the factored form of the derivative, I can see that I have 2 factors, so that's why I made 2 rows, one for cosine x and one for 2 sine x plus 1. Also, we have to begin and end with 2 pi because we're told from the beginning that that's an overall limitation. Now we need to determine if these factors are positive or negative in each interval. Let's start with cosine. Normally I would pick a test value in each interval, and I will have to do that when I get to 2 sine x plus 1. But cosine is so simple, I don't need a test value. Cosine is simply the x value on the unit circle. So between 0 and pi over 2, are x values positive or negative? Yeah, they're positive in this quadrant, so I just know this is positive right away. What about between pi over 2 and 7 pi over 6? Well, x values are negative over here on the left side of the unit circle, so I know this is negative. What about between 7 pi over 6 and 3 pi over 2? Well, we're still over here on the left side, so x values are still negative over here. What about between 3 pi over 2 and 11 pi over 6? Well, we're on the right-hand side now. X values are positive over here. And it'll be the same story between 11 pi over 6 and 2 pi. We're on the right side of the unit circle where x values are positive. As we switch gears to the next factor of 2 sine x plus 1, we will need some test values. So in the first interval between 0 and pi over 2, let's use pi over 4. So we're talking about 2 sine pi over 4 plus 1. Well, everything that we're looking at is going to be positive. So we know this is going to be positive. You know what I mean? Because sine of pi over 4 is positive radical 2 over 2. So it's positive. All right, let's move on to the interval between pi over 2 and 7 pi over 6. So sitting right in that interval is pi. So let's use that as a test value. So we have 2 sine pi plus 1. Sine is the y value. So the sine of pi is 0. So this is going to be 2 times 0 plus 1, which is just going to end up being positive 1. So that is going to be positive. Between 7 pi over 6 and 3 pi over 2, there is a value of 3 pi over 4. Let's use that because that's one of our special angles. So sine of 3 pi over 4 plus 1. Well, 3 pi, the sine of pi over 4 is radical 2 over 2. We're in the third quadrant where sine is negative. So this is going to be negative radical 2 over 2. So we have negative radical 2 over 2 times 2 plus 1. These 2's will cancel each other out, so we have negative radical 2 plus 1. This is going to be a negative value because radical 2 is bigger than 1, and it is negative. So the negatives win. So this is going to be a negative value. Between 3 pi over 2 and 11 pi over 6, there is a value of 7 pi over 4. That's one of our special angles. So let's do 2 sine of 7 pi over 4 plus 1. The reference angle is pi over 4, so we know that this is going to be some kind of radical 2 over 2 in here, but because we're in the fourth quadrant, y values are negative down here, so this is going to be a negative radical 2 over 2. So this is the same exact situation as before. The 2's cancel out, you have negative radical 2 plus 1, the negatives win. So this is a negative value. For this last interval between 11 pi over 6 and 2 pi, you would be wise to be reluctant to use 2 pi itself because it's on the border of your interval. Sometimes this will be excluded. But you can think of it as using a value that is really close to 2 pi, but just a teeny tiny bit less than 2 pi. So if I accidentally go ahead and put in 2 pi as a placeholder, but understand this is not really 2 pi that I'm putting in. This is really a teeny tiny bit less than 2 pi. All we care about is the sign. So it doesn't matter that our answer is not exact. It's going to be really close to the right answer. So it'll be close enough for positive and negative. Sine of 2 pi is 0 because it's the y value. So fine, it might not actually be 0, but it would be really close to 0 if you were a teeny tiny bit less than 2 pi. So still, that doesn't matter. It's still going to give you a positive result because this will be if it's not 0, it's really close to 0. Okay, so it's a positive result. Now, what about the overall value of f prime? A positive times a positive is a positive. A negative times a positive is a negative. Negative times a negative is a positive. And a positive times a negative is a negative. Positive times a positive is a positive. So we know that the original function will be increasing wherever f prime is positive and decreasing where it's negative. So f of x should be increasing in this interval, decreasing in this interval, increasing, decreasing, increasing. So let me erase this and write some of that down. Let's start with the increasing intervals. F of x is increasing from 0 to pi over 2, and from 7 pi over 6 to 3 pi over 2, and from 11 pi over 6 to 2 pi, because f prime is positive. Don't forget your justification. F of x is decreasing from pi over 2 to 7 pi over 6, and from 3 pi over 2 to 11 pi over 6, because f prime is negative. What about the relative maxima and relative minima? So if you look at my little hints here that I wrote down about f of x increasing and then decreasing, you can tell that there must be a relative max here at pi over 2. But you can't say for a justification that there is a max at pi over 2 because f of x is increasing and decreasing. All the work we've done has been using the first derivative test. So you have to use the first derivative in your justification, like this. You have to say f of x has a relative max at x equals pi over 2 and 3 pi over 2 because f prime goes from positive to negative. Similarly, we can tell because of the increasing and decreasing pattern that there is a relative min at 7 pi over 6 and 11 pi over 6. It's decreasing and then increasing. Obviously, that's the bottom of a little valley. Decreasing, increasing. This is a min. But you can't use the decreasing, increasing argument. You have to say f of x has a relative min at x equals 7 pi over 6 and x equals 11 pi over 6 because f prime goes from negative to positive. I know this is kind of a lot, but you got this.